On November 9, astronomers around the world found themselves staring at two images that seemed almost impossible to explain. One came from the James Webb Space Telescope, while the other was released by the Virtual Telescope project. Both focused on the same mysterious visitor from interstellar space, an object known as 3I Atlas. At first glance, the images looked ordinary. But the longer scientists studied them, the more unsettling they became. Instead of displaying the long glowing tail expected from a comet approaching the Sun, the object appeared as nothing more than a compact, brilliant point of light. There was no expanding cloud of gas, no stream of dust, and no visible evidence that sunlight was stripping material from its surface. According to everything astronomers know about comet physics, this should have been impossible. As icy objects travel closer to the Sun, intense heat causes frozen gases to vaporize, creating spectacular tails that can stretch for millions of kilometers. Those glowing clouds are among the defining features of every active comet ever observed. Yet 3I Atlas showed none of them. Even more surprising was the fact that it looked almost identical to images captured months earlier by the Hubble Space Telescope. During that time, the object should have lost billions of tons of material as solar heating intensified. Instead, its appearance remained remarkably unchanged, as though the Sun had no effect on it at all. For many researchers, this was simply another unusual astronomical puzzle waiting to be solved. For others, it hinted at something far more extraordinary. Harvard astrophysicist Avi Loeb described the observations as a reminder that nature can still surprise us in ways we never expect. If the images truly reflected reality, then this mysterious traveler was behaving unlike any comet previously recorded. The mystery deepened as astronomers tracked its journey toward perihelion, the point where it passed closest to the Sun. Rather than slowing under predictable gravitational influences, the object began drifting away from its expected trajectory. The deviation was small enough to escape casual notice, but large enough to capture the attention of orbital analysts around the world. Careful measurements revealed that its path had shifted by several arcseconds. At a distance of hundreds of millions of kilometers, that tiny angle translated into a displacement spanning tens of thousands of kilometers. Something was changing its course. Calculations showed a steady outward acceleration accompanied by a sideways drift that continued for weeks. By the end of a single month, the object's position differed from predictions by more than 80 kilometers. Random measurement errors couldn't explain it. Neither could gravity alone. Observatories from Hawaii to Chile began comparing their observations, searching for an answer. The obvious explanation was outgassing. Normally, jets of vapor escaping from an icy nucleus act like tiny rocket engines, gently pushing a comet away from its predicted orbit. But this explanation immediately ran into a serious problem. If enough gas had escaped to create the observed acceleration, the object should have been surrounded by an enormous glowing cloud visible even through modest backyard telescopes. Nothing appeared. No halo. No dust. No tail. Only the same bright, compact point of light. To highlight the mystery, the Virtual Telescope project compared 3I Atlas with the well-known comet Lemon, photographed under nearly identical observing conditions. The difference was impossible to ignore. Comet Lemon displayed a magnificent tail stretching away from the Sun exactly as physics predicts. 3I Atlas showed nothing. It looked perfectly clean, perfectly symmetrical, and strangely untouched. The contrast was almost surreal. One object behaved exactly as every comet should. The other ignored nearly every rule astronomers expected it to follow. For Avi Loeb and his colleagues, the numbers became increasingly difficult to reconcile. If ordinary cometary activity were responsible for the observed acceleration, The escaping gas would have produced an enormous luminous cloud brighter than many familiar objects in the night sky. Yet every new image continued telling the same story. Nothing surrounded the object. Its brightness remained steady. Its color remained unchanged. Its nearly perfect symmetry refused to disappear. Even instruments specifically designed to detect faint traces of dust returned essentially the same result. 0. That was the moment many researchers realized they weren't dealing with a simple observational error. They were facing something that existing comet models struggled to explain.